What are you wearing that witch's hat for, Jenkins? Oh, no, it's not Halloween again. Quick, turn the lights out. Right, quiet, Jenkins, otherwise I'll have the little buggers knocking. Shh, shh, quiet. Now go away. Oh, for God's sake. If it's teenagers that have made no effort, they can... Oh, hello. Oh, come in. Who are you? Oh, it's Sheriff McClaw. Here, Jenkins, give him one of your biscuits. Billy. No. Hello, welcome to Tweed's Garage, where on this episode we're working on the Bsa Bantam again. Working through some electrical items. So we're doing a horn repair and we're fitting a new rear light, number plate bracket, and a little bit of engineering thrown in, making up some new screws for the airbox. These ones here, so I'll show you how to make these. Yeah, I think that's all. That'll do you. So come on, let's go and have a look. This way. No, this way. First I've got to take the old number plate bracket off. Had a little go at it and the nuts are quite tight on there and rusted up. So I'm going to use some release spray. I've been soaking it for a little bit and then I'll give it another spray in a bit, but I'm going to heat it. I'm going to use these little blow torches are really good, actually, really useful. Quite a very fine, I don't know if you can see that, very fine flame on, and they get up to a nice temperature and very good for doing sort of spot heating on nuts and bolts, so you sort of don't damage the paintwork around the area. So I'll be using that and using release spray, not WD-40. People keep using WD-40. WD-40 is a surface lubricant. What you need is penetrating oil, which is what this is. WD-40 is not penetrating oil. Right, save me piece, move on. And there we go, one number plate stroke light bracket removed from the back of the bike successfully without breaking any of the bolts. I'm going to replace this because it has done its time. You know, I could spend time cutting all this rotten piece out and a new lip and welding it on, but you know, seriously, it was only a cheaply produced part in the first place, and it's done its time. It's sort of broken round there. It's obviously been bent along here. You can see the stress point running all the way through, and it's full of filler from there right up to there. And even more annoyingly, it's not even symmetrical. It sort of tapers down this way, and this side's a different shape to that. So it wasn't even good when they were new. So I think we've got a reproduction from, I suspect, India, but it looks reasonable enough. Powder coated so it can go straight back on. Got a reproduction Y-pack light to go on because this one's broken underneath, and you know, it's all a bit corroded, and the seal's gone at the back. So yeah, don't feel guilty about replacing any of this. So this is the new rear light, sort of a copy of the original Y-pack one, a reasonable quality one. Yep, so that can go on. That could go straight on. It's got these fly leads here with connections. The sub-assembly loom that came with the main Lucas loom has a longer length of cable that will run from the light to the battery compartment to do the connections. So I'm going to use this one. I'm going to wire it, take these out, wire it into the light. It just does away with one well, another 3 connections. You know, the less connections you've got, the better really. And what I've also done is it didn't come with an earth wire. It comes with an earth wire on here, but not on the loom that come with the Lucas copy. So yes, I'll put an earth wire on there just to make sure we get good electrical contact down at the light end. So let's take it apart, see if we can rewire it. Okay, put that somewhere safe so we don't lose it. Immediately loses it. Move the bulb. And then this should push out like this. And is it keyed? It's not really. It's got little tabs there, so it goes in and locates the correct way, but you can get it in 180 degrees the wrong way. So need to keep an eye on that. I'll just, what colours we got? Black and red. Yeah, so I'll use black for black. And oh, let's see what they use for earth first. Okay, they use black for earth, so white in place of black. I think brown is the brake light and black is the side light. So we'll wire that up. We might have to swap them over if we get it wrong. Okay, let's do that. Okay, let's remove the original. Put that somewhere so we don't lose it. It's over there, right. Okay, now we've done this. So the earth is just soldered on. Earth is soldered onto this washer at the bottom, contacts with the spring, which then makes the whole outer light unit your earth, or positive on the Bantam. And then these are the 2 wires, one for the brake, one for the side light. Snip that off there. And these should push through like that. And they are currently crimped on. I'll have to remove these and solder the new ones on. Don't really like soldering, but it's the only way around it because I haven't got any of these. And if we get them the wrong way around, we can just flip this round in the bulb holder to change them round. There we go. One spring, one washer. There we go. So we need to solder our earth onto there, which is the white one. So what I try and do is roll back these crimps, crimping the outer sleeve, like that. Roll them out of the way, nice pair around those pliers. Try and get them out for the crimped piece of the contact. Might be able to prise them apart a little bit and feed in the new wires. Right, I've decided rather than to try and open these little ends up, I'll end up damaging the contact, so I'm going to just grin and bear it and solder them on. So let's get the wires ready. Actually, let's make sure we get it all in the right order. So grommet first. What did we have? That goes on last. No, it doesn't. Yeah, that goes on last. Then the connector's on that. Spring behind that. Washer on that. And we can feed it through the light fitting. Strip these down ready. Sorry, I forgot to put it on record. So I removed this wire, I've tinned all these up and just soldered the earth wire to the earth ring. I'm just going to attach one of the contacts. There we go. Oh no, deliberate mistake. Were you watching? Can't put that on yet. This is what you've always got to check. Always got to check. So that goes down on that. That goes down. We've got our connector on. Run those through. Oh, it doesn't really matter actually. They would have gone through with the cables on, but these ones won't. These have got to go through first. There we go. Okay, who noticed the deliberate mistake? These have got to go through this. I blame Jenkins. Right, I'll be back in a minute. Right, we've tidied it all up again off camera. Difficult soldering with you lot watching. I think hopefully now, pop it in, just be careful. The trouble is these wires bunch under the spring and then they bind up the light fitting, so I just need to get the length of the cable just right. Okay, let's try the bulb again. High lugs this side. There we go. Easy. There we go, and then pop it on the mudguard. The only thing I might do is put some spacers, little washers under here, because you've got this bit of this recess. When you're doing the screws against a flat plate, you're sort of pulling the fitting in, you know, distorting it slightly. So I think just a washer under there just to level it off with the back of the mudguard, the number plate bulb holder, because the original one had captive threads, and where they were captive there was a little bit sticks down and takes up this gap. So there we go, nice shiny new number plate, lamp bracket. Does have the correct thread on it rather than a metric thread in there, so that's you know, that's good. Says it's powder coated, not sure if it is or not. It does look like it actually, so yeah, it saves me painting it anyway, and it should matte off fairly well. Powder coat after a while. So light wires in. Yeah, fits in okay. Didn't have any suitable washers, but I'll put a little couple of rubber washers under there. Just put a couple of rubber O-rings under there. Yeah, studs would have been better. Make life a bit easier. There we go. It's on there quite well. Got a slight problem there, the bolt of the lamp fitting is hitting the bottom of the bracket there. It's not sitting flat. Yeah, so we've got to take a bit off of there, which I don't really want to do. But to be fair, the original they were rather conservative where it was going to fit, so Yeah, you can't blame the manufacturers of this too much. Ready to go back on the bike. So out with the old. The only thing the new reproduction bracket didn't have was this little cable support bracket welded to the underside of the light support, but everything else was pretty much spot on. There was a little bit of discrepancy between these holes and this hole on the mud guard, but I got it to fit okay. We've done a little bit of what they call in engineering terms, a little bit of light forming, just a sort of little bit of light bending, gentle persuasion, just gained that distance of these holes lined up with the holes in the mud guard, and yeah, it's pretty good. And I don't think it's powder coated. I think it's actually stove enamelled, because it is a bit prone to. Well, you can see there, that looks like a stove enamel where it's sort of been held and painted, and it sounds like stove enamel as well. So pretty hard wearing, not bad for the money, and yeah, just tidies the back end up a bit. So with the rear end sorted out, time for an engineering intermission. So I want to get the slot nice and central in the screw. So we're going to find the vertical centre with this touch sensor or touch centre finder. So get it close to the job. Then move it down so it's roughly in the centre. Knock it down. Okay. Oh, a quick demonstration of how it works. And then we bring it in. Let's move it in a bit. I'm literally working around you guys. The camera's right in front of me. So, apologies. It looks a bit ramshackle. And then we bring it in slowly till it touches. We zero it. Keeping the same height. And bring it in from the other side. There we go. And then we half it. So then we can move our cutter back to the middle, which is there, and lock the table down. Okay, so then we put the cutter in. Right, and then we want to find the vertical centre for the cutter to run in. Because we're only cutting in aluminium. I'll move it down on the quill and lock it to get it close. You can have the cutter running to bring it down, so you just touch off on the part. But as it's a finished surface on the outside, I don't want to mar it too much, so I'll just bring it down. Just rest the cutter on the top, knock the quill down, and then we work out what our half reading is to bring the cutter. I'll bring the table up to drop the cutter down. Then we're ready to bring the table up. So set my dial to 0. So the cutter is 5/64, so we'll convert that to a decimal reading, so it's 0.0781. And then we measure our part, which is 0.6345. So then we add the two together, which gives us 0.7126, and then we divide by 2. So divided by 2 gives us 0.3563. So we need to bring the table up this much to set our cutter in the middle. So 3563. So 1, 2, 3,000. 500 and 60, and then 3. About there. Ready for my coin to go in. Undo it. See? How are you going to do that with a cashless society? Do, do, do. Call out the RAC man. So the last electrical item to look at was the horn, which didn't work. I did try putting 6 volts across it, but nothing happened, but there was no arcing either, so I suspected there was no continuity. So the first thing to do was check it out with a multimeter, and as you can see, as suspected, there's no continuity there. On the coil, we're checking the continuity on the coil. There's a coil inside the horn. I've done a horn strip down before, but you may not have seen it. It was on the Riley, one of the tannoy horns, and they all work on the same principles. So how it works, so you've got a copper coil in the end here, and when 6 volts or 12 volts is put across it, it causes a magnetic force in the centre of it, and that draws down this steel plunger that's mounted on the back of this thin steel diaphragm. And this is what makes the noise. This moving backwards and forwards produces your horn noise. And so how it works is you see a little groove in the back of this steel rod, and that engages with this finger that is connected to a set of contact points like you get in your distributor. Same sort of thing, just a set of contact points there. So it's a make or break switch. So what happens is initially they're closed, you put voltage across, magnetic force is generated, diaphragm moves down, and as it moves down it pushes on the finger and disconnects the voltage coming in. So with the voltage disconnected, the electric force is dissipated and it releases the steel rod that's been pulled down, and the spring in the diaphragm allows it to spring back up again into its home position. And so of course it comes up, and in doing so it closes the contacts again, and then voltage will flow again, down it will go, voltage stops, magnetism stops, plunger comes back up again, and that's how it works. It's sort of constantly like that, moving up and down, and because the frequency is so fast, that's how you get your noise generated on this steel diaphragm, and it's as simple as that. So the problem is we're not getting any continuity, and what I suspected was it's either two things. It's either broken wire on the coil, or as it is, I suspect on this, it's the contacts need cleaning. Like when you have to clean your points, they get a bit crudded up, and then and because it's been sitting for so long, it's corroded away a bit, and continuity is lost. So we're going to clean those. To get into it was quite tricky. This is why people buy new ones. So they're held together with these little steel hollow rivets that they use in the sort of manufacture of these things. But don't worry about it. You can get round it in many ways. So what you do is you just drill them out, just till you get to the surface of the sort of outer bezel of the horn, and then once you've drilled the top of the rivet off, you just drift them out with a suitable punch and knock them out. And then you'll find once they're all out, the horn comes apart fairly easily. It was a bit sticky because the sort of gasket paper was sticking to the diaphragm, but managed to get it apart. And then you can see it in all its simple glory. So you could get hold of the rivets probably. I haven't really looked, but because I've got a lathe, I've just turned some little brass ones up, solid at one end, and just sort of drilled down in the middle of them, so there's enough hollow there so I can put a centre punch down it, put it on a flat surface, centre punch in the back of it to spread it out, and then just peen it over on the back of the horn to secure it back together. But you don't need to do that if you haven't got the facilities, and you can't get the rivets. The other way is just, you know, a small set of close fitting screws and nuts will put it back together how they used to do it. Or you could even find find out what size it is. I think it's 4.5, so you might be able to sort of tap it out to 5mm, you know, just with some 5mm screws in the top there, little round head screws. Put it back together that way. It's just a case of getting it back together. There's no great stresses holding it together. So yeah, you could do it with, yeah, tap it, little screws, bit of Loctite, put it back together, and then you can get in if you needed to service it again. So sometimes even those things look like they can't be serviced, if you can get into it by drilling out sort of rivets or little welds, there's always ways around of putting it back together mechanically, you know, so you can repair it and reuse it. And now I've cleaned the contacts. When I put my meter across and just touch the bottom contact pad, we've got continuity, and if I push down on the finger, disconnects, reconnects, disconnects, reconnects. So that can go back together. And then once we've got it back together, there's just a few adjustments. There's the back stop to stop the shaft going down too far, adjusted with undoing this nut and moving this in and out. And then the other adjustment is to move this points plate up and down in relation to the stroke of the diaphragm. So that's how sometimes you might get a horn that will just go bip, will just do an initial noise, but then won't go any further than that. And you can find, if you adjust the tension, adjust the points plate up and down, you can find a sweet spot where you get that nice sort of vibrating horn noise that you want to hear. Okay, so there we go. So let's pop it back together. So that goes in there, making sure we hook the points finger in there, like that, like so. What we'll do is pop that on, because that does go through the bezel, so we can tighten that up easier in the vise than we can trying to get a thin spanner under there. There we go. And then try and put it back. I'll try and put it back the way it came out. You can see the paint sort of missing mostly there, which was over there, so we'll pop it that way. Make sure that finger's engaged. There we go. And then drop the ring on. I've got the contacts there, here, so yeah, I just want to put the Lucas at the top if I can. Will it work? No, I have to go to one. I'll go that way. Yeah, to the side a bit, that'll do. Not that it matters. And just centre everything up. Okay, now I've got a mounting plate to go on, so I only need to rivet 4 of the holes. I'm not sure where I'm gonna put it so it goes behind. I'm going to put it there, so the terminals are behind it there. So I need to rivet that one, that one, that one, and that one. There we go, they're sort of initially tapped over, but I'll put a bit of voltage on and see if it makes a noise first before we rivet those over finally. I can still get in there and to do that rivet, so this bracket will help hold the horn together whilst I'm riveting it. There we go. And an engineer's clamp on the other side just to sort of keep it all nice and tight together, and then we'll put a bit of voltage on it and see if it works. Right, it's got it working. Let's see if we can change the tone on it. About there's the sweet spot. See if we can keep it there. it's got to be. There we go. Rivet it together. Okay, so it's time to peen these brass rivets over as we've got the horn working. Hopefully it won't need any more adjustment, but most of it I can do from the outside, so it's not a problem. So, selection of punches to sort of start spreading them over. Thin one just to go in the hole and spread it over a little bit, and then another one to move it over a bit more, and then I ground this sort of radius profile one up to move the flanges over and flatten them down on the body of the horn, and then I'll finish it off with a flat punch to bed it down on the back of the horn. Okay, so give you a little demonstration. Hopefully go all right. Get a little bangy tool out. There we go. So it goes in there. Make sure it's resting on the vise. Give it a little. A little bit over generous with the tapping. Oh. Where were you? Where were you? You're back. Okay. You're back. Just give my punch a little bit of a spin. I really have stuck that in there. Bear with. There we go. Right, one down. I'm going to taper it over a bit more with a bigger one. It's another free-handed job. There you go, it's starting to bite on the back horn plate. There we go. And then we'll ease it over with my special punch. There we go. Just move it around the edge. There we go, nearly done. Doesn't look too pretty. Just getting the job done. We get a big punch on. There we go. Punched over. We've just got the others to do now, and then it'll be done. So there we go, one Lucas horn repaired and ready to go back on the bike. We didn't need to buy a new one. Sort of all peened over like that. If ever you need to work on this again, you just drill those out, knock them out, make up some more, pop them back in, job's done. So there you go, rear end sorted out. So brake light and rear light working, functioning. I sorted out the original brake light switch as well, but I'll show you that on another video. A horn that works, a Lucas one that we can stick on back on the bike in its original position, and little bits and bobs made for the airbox. So with those bits done, we can sort of move back onto the engine. A few bits of repair to do on that, bit of welding just to build up the cases a bit. If you haven't seen that, I'll link the video for that one so you can see what problems we've got to sort out on that. Yeah, but I think that'll tide you over till next time. So if you like the video, give us a little like, and if you enjoy the content, subscribe, and I'll see you in the next one. All right, cheerio. Come on in, Jenkins. Let's go trick-or-treating. And bobs made for the airbox. So working. No, no, no. Lights that don't work, and the so there you go, rear end sorted out.